Hi everyone, welcome to the fourth session of Stereochemistry of Organic Compounds. Myself Sumalata S, Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we will going to discussing about the conformation isomers, conformational analysis of ethane, conformational analysis of 1,2-dichloroethane. Let's begin the session. Conformation isomers. These conformational isomers, also known as conformers, these are having the different spatial arrangement of molecule that can be interconverted by rotations around the single bonds. These isomers have the same molecular formula and connectivity but differ in the spatial orientation of their atoms, particularly due to the rotations around the sigma bonds. Here, these are the conformers of the butane. The butane has the formula of CH3, CH2 and CH2, CH3. Okay, this is the formula. Here what happens? This one carbon, second carbon is represented as this structure, line structure, and the other third carbon is represented as a circle. To this compounds are attached. Okay, here in case of, there are four structures. One is the fully eclipsed one, means the one group is present exactly backside of the other group. Okay, those are having the dihedral angle of 0 degree. Okay, if we rotate this backside molecule with the 60 degree, okay, what happens? We will get the another structure. This is termed as a gauge or staggered structure. Okay, staggered one. Okay, if one atom is exactly behind the other, means that is the eclipsed one. If one is present at an angle 60 degree with the other one is termed as the staggered one. Okay, here in case of staggered, there are again two types. One is the gauge, other one is the anti. Okay, in case of gauge, the two similar groups which are present adjacent to each other. Okay, next what we are going to do? We will again rotate this molecule with the 60 degree. Here what happens? We will get the eclipsed structure, means one is behind the other. But here what happens? Here methyl group is behind the methyl group, hydrogen is present, means different groups are present. But in case of fully eclipsed one, methyl group behind this, one more methyl group present. Hence this is termed as a fully eclipsed. If two different groups are present, means it is only the eclipsed one. Okay, here dihedral angle is 120 degree. Again what happens? We will going to rotate this molecule. We will get this structure. Okay, here what is the angle? 120 plus again one more 60 degree. We will get the dihedral angle of 180 degree. Here one methyl is this side and other methyl is this side, means two methyl groups are exactly in the opposite side. Those is termed as anti-staggered. Okay, those are anti-staggered conformation. Okay, they can be easily converted into one another by rotations around the single bonds, often without requiring bond breaking. Conformational isomers can have a different energy levels, with some being more stable than the others. Okay, next coming to the conformational analysis of ethane. Okay, What is the formula for the ethane? Ethane is CH3, CH3. Okay, here this carbon atom to this carbon atom, 3 hydrogens are attached. Here this is the carbon atom, 3 hydrogens are attached here, and to this carbon atom here 3 hydrogens are attached. Okay, this is the one. Here ethane has the 2 major conformations. They are, one is the staggered one, other one is the eclipsed conformation. Okay, in case of staggered conformation, in this conformation the dihedral angle is 60 degree. The atoms in the front and back carbons are as far apart as possible, minimizing electron cloud repulsion and resulting in the lower energy. Means the, in case of staggered conformation, these are far apart as possible and these are minimizing the electron repulsion, resulting in the lower energy. The staggered conformation, where hydrogen atoms on the adjacent carbons are far as apart as possible. Hence, due to this, there is less repulsion between the atoms. Hence, this is having the more stable conformation, and this is due to the lower torsional strain. Next, coming to the eclipsed one. Here one atom is present behind the another. Here dihedral angle is 0 degree. The atoms on the front and back carbons are directly aligned, and this maximizing the electron repulsion, resulting in the higher energy. Due to this eclipsed one is the less stable and it is having the higher torsional strain. Okay, staggered one is the more stable one, eclipsed one is the less stable one. Next, the torsional strain. What is this torsional strain meaning? The energy difference between the staggered and eclipsed conformations is called the torsional strain. Okay, this is the energy difference between the staggered one and eclipsed one. This energy difference is termed as a torsional strain. Okay, this strain arises from the repulsion between the electron clouds of the CH bonds. Okay, see here this is the eclipsed structure of the ethane. Here one hydrogen is aligned exactly back of the other hydrogens. Here dihedral angle is 0 and we will represent this as a red color. Okay, due to the rotation. Okay, in sake of understanding the rotation of the molecule. In next structure, what we have to do here, we will rotate this with the 60 degree. What happens? We will get the staggered one. Okay, this is also called as a Gauch staggered. But here that Gauch word is not mentioning. Why? This is because all other atoms are identical. Hence, we will represent this as only the staggered conformation. Okay, if any different groups of atoms are present, means we will going to represent it as a Gauch conformation and anti-conformation. Due to the identical hydrogens attached to the carbon atoms, hence we are only representing this as a staggered one. Okay, next we will get this conformation. After again we will going to rotate this with the again one more 60 degree, then it becomes 120 degree. Okay, we will get this structure eclipsed one. Next again we will going to rotate this with the one more 60, means 120 plus 60 180 degree. We will get this staggered one, again 60 degree, that is 120 plus 60 240. We will get eclipsed. Then again one more 60. We will get this staggered. Again finally we will at the 360 degree we will get the identical one as the initial. Okay. The energy difference between this staggered and eclipsed one is the 3 calorie per mole. Okay, 3 calories per mole. This 3 calories per mole is also termed as a torsional strain. Okay, this is about the conformational analysis of ethane. Okay, next coming to the conformational analysis of 1,2-dichloroethane. The conformational analysis of 1,2-dichloroethane reveals 3 major conformers. Why? Because what is the structure of 1,2-dichloroethane? It is Cl, CH2, CH2 and Cl. Okay, this is the 1,2-dichloroethane. Here what happens? There is a different groups attached to the carbon atoms, right? One is the chlorine and other two are the hydrogens. Hence, here we are getting one is eclipsed conformation, and in case of staggered we will have the 2 conformations, that is the Gauge conformation and anti-conformation. When we going to get these conformations? When the molecule is rotated, initially when the dihedral angle is 0 means we will get the eclipsed one. When we rotate this with the 60 degree, okay, we will get the Gauge conformation. When we again rotate with the one more 60 means 120 degree. At that 120 degree, we will again get the eclipsed one. Okay. When we rotate this eclipsed structure with the one more 60 degree means that is dihedral angle of 180 degree, then we are getting the anti-conformation. Okay. And see here, we already discussed staggered conformations. Staggered conformations are more stable than the eclipsed one. Okay. So, by the order of stability, eclipsed one is the least stable. So, we will represent here least stable. Okay. But in case of staggered, there are sorry for interrupting. In case of staggered, there are again 2 conformations. One is Gauge and other one is the anti-conformation. Okay. Here in case of Gauge, what happens? The 2 identical groups present on the adjacent, right? So here what happens? There is a still more electron repulsion. Hence this Gauge conformation is next. After that anti-conformation means here the identical groups are exactly in the opposite side. Hence there is a less repulsion. Due to that, this is anti-conformation is having the most stable conformation structure. Okay. So order of the stability is anti-conformation is more stable than the Gauge conformation. This is in turn more stable than the eclipsed conformation. Okay. See here. These are the structures of the anti-conformation, Gauge conformation and eclipsed one. Here what happens? The 2 identical groups are aligned exactly one backside of the one behind the other. Hence there is a more electron repulsion. Hence this has the lesser stability than compared to Gauge. Here Gauge, in case of gauge, the two identical groups are adjacent. Hence, here this is some more repulsion is present here in case of gauge conformation. Hence, it is compared to eclipsed, gauge is more stable. Okay. In case of anti-conformation, the two chlorine atoms which are present opposite side, hence there is a less electron repulsion, hence this has a more stable conformation. Okay, so anti-conformation is more stable than the gauge conformation, and this in turn more stable than the eclipsed conformation. The anti-conformer is the most stable due to the minimized steric repulsion between the chlorine atoms, while the gauge conformer is less stable due to the increased repulsion. The eclipsed conformer is least stable due to the maximum steric repulsion. Okay, this is regarding the conformational analysis of the 1,2-dichloroethane. By the end of this session, we came to know about the conformation isomers, conformational analysis of ethane, conformational analysis of 1,2-dichloroethane. By the end of this unit, we came to know that concept of isomerism and their classification, optical isomerism, optical activity, configuration, chiral carbon and molecular dissymmetry, optical isomerism in the tartaric acid, enantiomers, diastereomers, meso compound and racemic mixtures, racemization process, geometrical isomerism, stability of the geometrical isomers, Ez nomenclature, and finally conformation isomers. In that, conformational analysis of ethane and 1,2-dichloroethane. The important questions regarding this unit are: thank you for watching.